Hello, let's continue our Sudoku adventure with Three Color Problem by Matt Tressel. This is the final puzzle of our Killer Cage theme week. This is going to be a very creative one. So I hope you enjoyed the Killer Cage week, and I hope you enjoy this puzzle. Let's go over the rules. We do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. We're also shading cages, one of 3 distinct colors of our choice, such that no 2 cages of the same color share an edge. So I'm going to be using green, purple, orange, just because they're in a row on my keyboard here. So if these are green, then this can't be green and this can't be green, right? Because they share an edge with the green. This could be green, though. That would be fine. Now, each cage of the same color must sum to the same amount, but each of the 3 colors will have a unique sum. So if this was green and this was green and this was green, then all 3 of these cages will sum to the same exact amount. These 2 digits will sum to the same as these 2 digits, which will be equal to this digit. But because this shares an edge with green, let's say that this is purple, it has to have a different sum than green. All right, and that's it. Those are the rules. There is no rule here saying digits can't repeat in a cage. I think that might be because there's nowhere where you could. So that's fine. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, so the question is where to get started coloring. I want to start where this 3 is here. So we'll make this green, and then we'll just arbitrarily choose, let's see, this as purple. Because what that does is it makes this touch green and purple, meaning this has to be orange. Now, see, the question is how to keep spreading from here. There might be like a really specific location where spreading is easier. Like down here, we get all 3 colors. Yeah, actually, I'm going to start down there instead. Let's just make, I don't know, this is green, this is purple, this is orange. And now this sees purple and orange. Sorry, this sees green and orange. Sorry, it touches green and orange. So this is going to be purple. And now this touches green and purple. So this has to be orange. And now this has to be the green. It touches purple and orange. Now this one touches green and orange, so it has to be purple. This could be green or orange. This touches purple, could be green or orange. Okay, can we spread this further? This cage here touches the orange and the green, so it has to be purple. Now this touches purple and orange, so it has to be green. And now this, actually, not now this. I don't know that this spreads further, does it? This touches just one of them. Okay. We may have to hold off. Let's see. So we have a single cell orange and green. So this is interesting, right? We know what green is because green is this 3-cell cage here. So what's the minimum I could put in here? Even if we could repeat digits in the cage, we can't repeat it in the box. So 1, 2, 3 are the smallest digits I can put in a 3-cell cage, which hopefully if you've been following along with Killer Cages, this has been ingrained by now. But 1 plus 2 plus 3 is 6. And that's the biggest digit we can put here. So that's what we have to do. We have to minimize this cage and maximize this cage, meaning green adds to 6. Now, that means purple cannot be any of this cannot be purple and this cannot be purple. We know that because purple also is 3 cells, but it can't add to 6 because we know 2 colors of the same colors. Sorry, colors. Cages of different colors have to have different sums, and 6 is used. So these 3-cell cages that we have for purple tell us that these are 7 or bigger, which means these single-cell cages can't be purple. So this one has to be orange. Does that help me? Well, we know this one's not orange now, and it can't be purple, so it has to be green, and it's a 6. Now this cannot be 6, but it is single cell, so it's orange. Right, it can't be 6 as a 6 in a row, so it can't be green because green is 6. Can't repeat green in a single cell. So we know orange is actually less than 6. So orange cannot be any of these 3-cell cages, but we already know that it touches a 3-cell cage. But this only touches orange. It could be green, technically. It has a 3 in it. It could be 1, 2 with a 3 in it. I wonder if this 3, I wonder what purple adds to. We can think about the possibilities here, right? Because orange is at least 3. But orange can't add. Oh, this is interesting. I was saying orange is at least 3 because there's a 2-cell cage here that's orange, and 1 plus 2 is 3. But there's a few problems with this. First of all, we'd have too many 1, 2, 3s in this column. So that's the first problem. The second problem is that this sees a 3. So actually 4 is the minimum. But if you look, 4 has to be 1, 3. That's still too many 1, 2, 3s in this column. Basically, I have to include at least a 4 in this orange. Because if I'm only from 1, 2, 3, I have too many 1, 2, 3s in here. Which means that 1 plus 4 is our minimum that I can put in this orange cage, which is 5, which is our maximum for all these single cells. So orange is 5. 1, 4 pair takes 1 out of here, places the 1 here. But now we know what purple is, because we know what a box adds to. All rows, columns, and boxes in a 6x6 add to 21, because they contain 1 through 6 once each. 1 through 6 adds to 21. We know that this adds to 5 and this adds to 6. So 5 plus 6 is 11, so these have to add to 10. In fact, we know what digits go in here from the box. This is 2, 3, 5. Places the 5. So we know that purple is 10. Interesting. Well, if purple is 10, then what I was hoping to prove was that purple was a sum that couldn't use a 3, but unfortunately we just showed it can. But there's no 5 in this cage. So I guess I think there are ways to do it, but if this added to 10, because this is going to add to 10 or 6, right? If it added to 10, this is already 3, so these two would add to 7. So we could be 1, 6. Only 1, 6 though. So this would be the 1, this would be the 6. I can't roll that out. So we could be 1, 6, or we could add to 6, which would mean we'd need a 1 and a 2. So that's the only possible values, which does mean there's a 4 down here. So this adds to 10. So we know what this adds to, right? This adds to 10, this adds to 6. So we basically need a 10, 6, and 5 in each box. Right? So this is the orange. That's to 5. It's not 2, 3, so it's 1, 4. Making this a 6. Oh yeah, any 2-cell purple is going to be 4, 6. These, we know what this digit is. This is a 5, and then this is 2, 3. This 3 tells us this is 2, this is 3. That makes this a 1. And it's with a 2 or a 6, but we still don't know what color this is, I think. That's 4, that's 1. This is not green or orange. Oh, that's been there. This is not green or orange. This is purple. We know that a 2-cell purple is 4, 6. That's our 4, that's our 6. That makes this a 2, and this does see purple and orange. Darn, I didn't need all that logic. That's okay. That's 1, that's 4. This is a 4 for the box or row. This is 2 or 3. Well, we know it adds to 6, so it's a 2. It's 3 and 2. I feel like there's a lot we can finish up here, but let's just see. The rest of this column is 1, 3, 6. That's not 1, that's not 6. Let's see. This cannot be purple. Let's see, what are the digits remaining here? We need 2, 3, 5. So that's our 3, that's our 2, that's our 5. So Sudoku tells us. So that's our 6, that's 1, that's 3. So this adds to 5, so it's orange. What's this digit? This is a 6. So this can't be orange, which means it adds, and it can't add to 6 because it already has a 6 in it. So this has to be purple, making it a 6, 4. This can't be orange or purple, so this is green, and this is a 1. There we go. Neat puzzle, Matt. I don't know how I missed this cage for so long, but that's okay. I did some neat logic while missing that. Cool. This was a neat puzzle. I enjoyed thinking about the various aspects of it. A really nice way to wrap up our Killer Cage theme week. Let me know how you did, and if you enjoyed it, why not leave a like, subscribe, and a kind comment below.